Good morning. Today we're going to talk about price setting power in the context of an Edgeworth box. So there are a few things that we want to think about here. We've got two people. We have Ayanda, who has price setting power over Bongani B. So Ayanda is down in the southwest corner in terms of her origin, and Bongani is up in the top northeast corner in terms of his origin. Now, what you want to think of here is that the starting point that we have is that there is a point Z, which is their endowment. And when we're thinking about that, we want to think Ayanda and Bongani can both start at Z, and that's going to constitute their participation constraint. Now, the next thing we want to think about is that when Ayanda is trying to think about what she will do with Bongani, with price setting power, she does not have as much power as she has with take it or leave it power. All she can do is offer a price. And remember, a price is an incentive. Okay? It's something that she will offer Bongani in order to get him to do something for her. What this means is that if she wants to maximize her utility now, she cannot determine both a price and a quantity like she could in take it or leave it power. She can only determine the price and find a price at which she will do her best. So what this means is she has to find Bongani's offer curve or price offer curve, which is also his incentive compatibility constraint. So we have the offer curve, which is equal to the incentive compatibility constraint. And as we'll see a little bit later, the idea here with the offer curve and the incentive compatibility constraint is equivalent to our earlier idea of a best response for Bongani. Now, here's what we want to think of. Aisha has to go through a process. She needs to think about a series of prices at which she can potentially charge Bongani and say, Bongani, here I will give you the following price, and then you can exchange with me the quantity that you choose. When she does this, she's basically thinking, for every potential price that Bongani could confront, that she offers him, she will want to understand what he will then propose as an exchange. So to think about that, we're going to have to think about a variety of potential prices that she could offer Bongani. And we'll look at a few just to understand how this might work. So the first thing to think about is we would have a price that is going up here through Z. And we're going to think about that as having a price line, okay? And that line, minus P, which has a slope of minus P. And that minus P, P1 here, is a ratio at which they will exchange the two goods, X and Y. Remember in our example that we've got for Ayanda, we've got XA going from left to right, and we've got YA going from top to bottom. And we want to think about for Bongani, his XB goes from right to left, and his YB goes from top to bottom. Okay. Now, here we've spoken about coffee as X and data as Y, so kilograms of coffee and gigabytes of data. We've also spoken about apples and oranges and different kinds of goods that could constitute what we would have here. And so when we have a price ratio here, minus P1, that is simply a number of oranges with respect to apples, or a number of gigabytes of data with respect to kilograms of coffee, a ratio at which we would exchange these goods. That's the basic idea of what a price is. Now, if you are Bongani and your origin is here in the top northeast corner, and then Ayanda says, I will offer you this price minus P1, remember that that price is a constraint for you, and you are maximizing your utility given that constraint. So what does Bongani do? He finds the indifference curve, which is tangent to that price P1. And he would there have a tangency. Now, the way we're thinking about this initially is that there would be an indifference curve tangent at point Z to some price line tangent at point Z. So that would exist, okay? But that's not the only thing that we want to think about. We're also going to want to think about a variety of other price lines, okay? And so those price lines, let's think of another one. Another price line is going to go through the endowment, and we're going to get point P2, price P2. Remember the negative, the slope of that line is minus P2. And then what are we going to find again? We're going to find an indifference curve for Bongani, and that's going to be tangent. We're going to think about another price line and another point of tangency. I know that my lines here aren't particularly well drawn, but you'll have to forgive me. And we could draw another price line and find another point of tangency. And what we will see here, if we connect all of these lines, is that we'll be able to think about a line that connects every potential allocation here, where we have a tangency of the first price line, a tangency of the second price line, a tangency of the third price line, a tangency of the fourth price line, each with their own corresponding prices, minus P3, minus P4. And we could think about these as giving us different potential allocations, B4, B3, B2, and then back at Z. And this curve, what do we call it? We call it the price offer curve, or often just the offer curve for short. Now, when we think about this, and we dealt with it earlier in the course, we had to think about the idea that Bongani, when he is maximizing his utility, he will choose a combination of X and Y at different levels of prices, and each of those will be where his MRS from his indifference curves, his marginal rate of substitution, is going to be equal to the MRT, the negative of the slope of his feasible frontier. And here, a price line is simply a feasible frontier which gives us a ratio at which we're going to exchange goods. So in each context, at B2, at B3, at B4, Bongani is finding MRS equal to MRT. And when he maps all of those points out, he finds his price offer curve, or what we also call his incentive compatibility constraint for Aisha, or Ayanda. The other thing to think about here is because Bongani is thinking about a given set of prices and then maximizing his utility for each given set of prices. This idea is basically the same idea as we've had earlier for a best response. Okay, he is best responding to each set of prices. So Bongani's incentive compatibility constraint is his best response to each potential price that Ayanda could offer him. So this is the first part of thinking about how we would go about thinking about price setting power. We have established an offer curve or a best response function for Bongani, and then the next step will be to think about what should happen if we're going to have this offer curve and what Ayanda will do once she's established what this offer curve is. Okay, so we have established how we found Bongani's best response function, incentive compatibility constraint, or price offer curve. We now have to think, given Ayanda's understanding of what Bongani will do with respect to every potential price that she can offer him, she needs to now think, what should she do? Well, we know that she will say, given every action that Bongani has as given all his potential best responses, she must think about what she will do as her best response. And the thing that she wants to do is to find her maximum utility. Now, in an Edgeworth box, the way that we identify whether someone finds their maximum utility is to think about them finding a high indifference curve. And then when we think about that, we're going to think about, okay, well, she's going to choose the indifference curve, which is tangent to Bongani's best response function or his incentive compatibility constraint. And that point where she finds her indifference curve tangent to his best response function, incentive compatibility constraint, or price offer curve, we're going to label that point M. And Bongani will also have an indifference curve going through that point. Okay. Now the question that we have to ask ourselves is we have two potential questions. The first question is that point, okay, is it Pareto improvement over Z, the fallback position? Okay, so is M a Pareto improvement over Z? That's the first question we have to ask ourselves. And then we have to ask ourselves is M Pareto efficient? Okay. So what we first need to think about here is, in terms of the first question, what can we see? Right? We're going to have an indifference curve for Bongani. We're going to have an indifference curve for Ayanda, terribly drawn. Now with that indifference curve, what are we thinking? That's U1 A for Ayanda. Let me try and redraw this indifference curve. That indifference curve is U1A for Ayanda versus UMA at point M. For Bongani, we have U1B along point Z, and we have UMB for his indifference curve going through point M. So if we look at this, we can see that for Bongani, comparing point M with point Z, Bongani has increased his utility. What we can also see is that Ayanda has also increased her utility. Because both of them have increased their utility, point M, our answer to this first question, we can see that point M is Pareto superior to Z because they both have higher utility. At least one person is made better off and no one is made worse off. So point M is Pareto superior to point Z. That's our answer to the first question. We then have to think about the second question. And to answer that second question, is M Pareto efficient? We have to think about whether we have intersecting or tangent indifference curves. Now the point here is important. In order to find a Pareto efficient outcome, what we need is for the marginal rate of substitution for Aisha to be equal to the marginal rate of substitution for Bongani. And when we're thinking about that, we need to make sure that that occurs where the indifference curves for Ayanda and the indifference curves for Bongani are tangent. Now notice that at M, what we can see is that if we just quickly highlight the two curves, we highlight this curve here, we highlight for Ayanda here, we can see that those curves are in fact intersecting each other at M. They are not tangent. What that suggests then is that we have the marginal rate of substitution for A, the marginal rate of substitution for A, so MRSA. Here we can see it's flatter than MRSB, and so MRSA is less than MRSB. So Aisha's or Ayanda's willingness to pay in terms of her indifference curves is less than Bongani's, which means there are potential other gains from exchange. Now, what you might also recall is that when they have symmetric preferences, when we have XA to the 1/2, YA to the 1/2 for Ayanda, and we have XB to the 1/2 and YB to the 1/2 for Bongani as their utility functions, then what that implies is that we have a Pareto efficient curve that we've established before goes from one corner to the other, and when we have Y bar equal to 15, and we have X bar equal to 10. Those are the dimensions of the box. So there are 10 potential kilograms of coffee, and there are 15 potential gigabytes up for trade. Then what that's going to produce for us is an equation for a Pareto efficient curve, which is YA equal to 3 over 2 XA. And that is our purple line that we've just drawn here. And this Pareto efficient curve tells us every single point where we're going to have our Pareto efficient outcomes where potential indifference curves are tangent to each other. So we can see two things. Firstly, M is Pareto superior to Z, but M is not Pareto efficient. So what that tells us is we've got a Pareto superior outcome to the initial allocation or the initial endowment point, but this point at which they've arrived, point M, is not Pareto efficient and does not lie on the Pareto efficient curve. Now, the important thing here to think about too is that this is a consequence of Ayanda having less power than she did under take it or leave it power. When she had take it or leave it power, recall, she could determine an allocation at a different indifference curve for herself, tangent to Bongani's participation constraint, the utility that he had at his endowment. And at this point here, point F, what we would have seen there is that point F is Pareto efficient, but it is highly unequal. Okay, so F is efficient but unequal. Okay, so Ayanda got all of the gains from exchange there. She got all of the economic surplus. She absorbed all of that economic surplus herself. And having done that, she did better than Bongani did, and Bongani stayed on his participation constraint. He did not get any gains from exchange. Gains from exchange were very, very, very small, epsilon. Whereas here, if we're comparing Z and M, what can we see? We can see that Bongani has improved his utility, and Ayanda has also gotten some gains from exchange, but the gains from exchange do not produce a point on the Pareto efficient curve. So our improvements are such that there are increases in utility for both parties, gains from exchange for both, but they do not obtain a Pareto efficient result.